Nordics people how to dance on ice. Take it away.
Yes. Thank you. Yes, so I'm going to start now. Yes, my name is César, and today I'm going to talk about software builds of materials, also known as SBOMs for short. How many of you already know about the SBOMs, who are familiar with it? Okay, cool. How many use SBOMs on a daily basis? Okay, so that's good. It means that hopefully this session will help you to get into SBOMs more faster and really understand why SBOMs are really fundamental today for developers. And yes, I will cover quite a broad, large topics. We will first dive into software supply chains. I will talk about SBOMs, what SBOMs are, why they are important. I will look at some vulnerabilities that could have been detected quickly if using SBOMs. I will also dive into the Java tools that they are available to produce SBOMs. So I will cover a few things, and also I will have a demo where we are going to see how we can get SBOMs ready for Java. And so I decided to include this slide because I'm not famous enough. So this is my professional journey, kind of. I started 10 years ago as a software engineer at my former university after graduating from computer science. I did some research and development there. It was in Cuba, so I'm from Cuba. Cuba is this archipelago in the Caribbean seas. And yes, it's pretty warm there. So I really didn't like it that much. So I decided to adventure myself to know more about the world. And I really took the big journey because then I somehow got here into Sweden, and then I met something really amazing. Like I found snow. For those of you who are not in a country that has snow, like the first time you see the snow and you never see it, it's like, wow, this scene is so white. It's amazing. It's solid water that comes from the cloud and is very white. It's so beautiful. This picture is me, like in 2018, the first time that I saw the snow. It was like, wow, this is so cool. And yes, so this is my snow thing good time that I had. So I did my PhD. I started in 2018 at KTH. KTH is a technical university here in Sweden. So I finished my PhD, and then I joined SEB, which is a pretty large bank, one of the most important in the Nordics, where I am today a data engineer. And I write a lot of code, and I write a lot of Java code. And yes, that's me. That was a little bit my journey. So as I mentioned, I write a lot of Java code, and this is my software project most of the time. It starts like this yellow square here is, let's say, all the processes, all the components of my project. And one thing that it contains is some code. Of course, it's a software project. It contains code. So this circle, this blue circle, is all the code that I ship. And one thing that I have noticed is that from all this code that is contained in my project, there is only a tiny piece that is actually written by me. So all this code that I am building, kind of, that I am assembling, that I am shipping to my clients, only contains a single piece, small tiny, tiny piece that I able to understand. The rest is code that is produced by someone else that I just reuse because I don't want to reinvent the wheel. So, as you can imagine, this situation creates many challenges for me. And there is a supply chain, but not like this kind of supply chain that you know from manufacturing physical items. No, I'm talking about a software supply chain, which according to Wikipedia is composed of the components, the libraries, the tools, the processes used to develop, to build, and to publish our software artifacts. This is not the only definition of software supply chain. For example, according to Red Hat, it is everything and everyone that touches our code during the software development life cycle. So this is quite broad, right? I'm just going to show you another definition by OWASP. It says that software supply chain is composed of all the components that are involved in the creation and the distribution and the maintenance of our software. But from all the definitions, because there are many, the ones that I like the most it comes from Salsa. This says that the software supply chain is the sequence of steps resulting in the creation of an artifact, our baby. So it's everything in between our code and the baby. So if we look at the intersection of all of these definitions, there is something about components. There is components that are developed, that are maintained to produce an artifact. So this is definition base. And here is this is a perspective, like a very broad perspective of the software supply chain. We have on the left, we have the producer, the developers, is us. Like we write the code, and then this code enters into a journey, which the code is built, it's packaged, then there are some dependencies that are pulled at the build time, in the build system, and then once everything is packaged, the artifact is delivered to the consumer. And look that there is a loop there, because sometimes our artifacts is going to be packaged and it's going to enter and become a dependency, maybe, of another of our projects or for another projects. So this causes many issues, like as you can imagine, in such a complex process, there are many threats. So the attack surface is pretty large. Like, for example, the developer could submit unauthorized changes. So he or she can tweak the system and publish code, change the code base, and introduce vulnerabilities there. But that's not the only source. Like, the vulnerabilities could emerge even in the build system itself, which can contain vulnerabilities because the build system is also software. So everything is software here, is software components. The package index is also composed of software. And the dependencies, the third-party libraries that we reuse, so they are full of code. And code, as we know, is not perfect. It contains vulnerabilities. And we want to avoid that. So the attack vectors are quite diverse. And this is the software development life cycle that we have today. That's the reality. We have contributors for example, in the open source kind of space. We create pull requests. When we submit the pull request, then pull request is reviewed by someone in the project, and then it enters into a build pipeline. Then the code is compiled, then the code is packaged, then the code is shipped, and in all this process, I want you to notice that there are people, humans, We are imperfect. There are many, many layers of people there. And these people contribute to the attack surface. There are many, many misconceptions about open source software. First, I would like to mention 3. First, there is a misconception that open source software is safe. That's unfortunately not the case. The fact that our GitHub repo has a lot of stars on GitHub is a widely known project. It doesn't mean that it's safe, that it's secure. And also, the dependencies risks are very, very high. So there is a misconception that, okay, dependencies are kind of safe. I can reuse the dependency because look how many other people is reusing it. So this is a misconception. And also, vendors are not secure. The fact that our company, we are paying millions for this software vendor, it doesn't mean that it is invulnerable. So that's true. That's the reality that we have today. So the attack vectors are quite diverse. In this research paper published last year in 2023 by colleagues of mine from SAP, they did a taxonomy of all the attack vectors that they could classify in open source software, and they publish it. There is a website that you can look at, so you can see these 3 of different attack vectors. So what I did was I took the data for the paper, and then I created a word cloud. So wanted to know which are the terms there. This is what I found. I found that it had a lot to do with packages, which looks like they are legit, but they are not. There are exploits there. There are credentials, which are compromised. And then I even found very strange words like brand jacking, like typo squaring, like combo squaring. So as you can see, the attack surface is huge. There are many, many ways in which our project could be exploited. So third-party components can be compromised because, among many things, software is often outdated or it is not patched at the right time. And in particular, I feel that there is a lack of transparency. Like, there are so many dependencies, there are so many components, and we don't really know. Do you remember this blue circle at the beginning? So it's so big. And I don't know, as a developer, I don't know what I have there in the circle. So this has made me think that from all the attack vectors, that the focus of attackers have shifted from pushing malicious code to attack our system into making us, the users, to pull the malicious code from package managers, from package indexes, and then execute the malicious code ourselves. So this is just one example, the log4j vulnerability that we all know. It happens in 2021. It was huge thing in the world, not only in the Java world, but in the whole world. We all know because the world was crazy because of this vulnerability, that this dependency, log4j, whatever, I don't know. I'm just an organization and I'm using it, and suddenly I am a high risk. Like, it happens because of a dependency. This is the technical detail. So basically, it was it reused like the GNDA, a feature of Java, in which a special string could be crafted, and then this string was put into log4j, and then log4j just using Java reflection, it was loading a class from somewhere, and then the class was compiled, and then it could execute the class, and then this created reverse shell attacks, which is very, very, very dangerous. So what we learned from Log4j is that dependencies represent a very, very high risk, especially open source dependencies that are widely spread, like Log4j is still. And also that we have very complex dependency trees. Like some companies just found that they were using Log4j at the time the vulnerability was released and the world was in chaos. And these attacks could have been detected more quickly if using SBOMs. I would like to mention the second attack. This time, this is quite interesting because it has to do with the GCP Golan build pack. This is an all-compiled injection in 2022. And this is interesting because the attack happens in the build system. The build system is quite easy to understand. So basically, there is a build pack feature in GCP that takes your code in Go, and then it compiles the code. And in order to compile the code, it needs to use a compiler, of course. But the issue was that the compiler that it was using, it was not the latest version of the compiler. It was using the most compatible version of the compiler with respect to your code. So, as we know, compilers are piece of code. And this piece of code also contains vulnerabilities. So in this case, if an attacker found a way to figure it out which compiler we were using, and then use this compiler, these vulnerabilities in the compiler, it could have attacked our system. So then we learn the hidden risk of build systems. And that you should never assume transparency, even in the compilers, even in the most bigger vendors. And this has been detected very quickly using SBOMs as well. Final example, this is also super interesting. It has to do with the Mat.js min credential stealer last year. It happened. It happened in many places actually of the software build pipeline. But it is interesting because in this case, a malicious actor, they create a fake GitHub user account, and then they forked the Mat.js npm library, the project, and then they just rename it like Mat.js min, and then they was published into npm, and then what happened is that the malicious actor changed the code so that it include a Discord credential grabber. So the idea was to take the credentials of the Discord accounts from the users of the library, which they will just execute the root square of a number, and they will get the right answer. But at the same time, this malicious code will execute. And this is an example of brandjacking attack in which the actor takes the reputation of a well-known library, then change it a little bit, then publish it, and then every time something is published in the internet, someone is going to look at it and someone is going to reuse it, and this is what happens every day with software libraries. So we learn the hidden risk of package managers with this example, and also that the attackers are always trying to figure out new tactics to deceive developers. And this is another example that could have been detected quickly using SBOMs. So after these three examples, I have every time mentioned it could have been detected using SBOM. But what is an SBOM? Now you will know. So this is the definition. This is a very formal definition. It's like, for me, it's the definition of SBOM. It's from the National Telecommunication and Information Administration. It's a very, very large name, but it's a very important entity. So according to them, an SBOM is a formal, machine-readable inventory of software components and dependencies, information about those components, and their hierarchical relationships. I'm gonna go like piece by piece into this. So is an inventory of components. In the same way we have in the food the list of ingredients that is all the ingredients that are needed in order to produce this. So, but in the case of software, the ingredients are much more and much more complex, because as we know, we have our applications, and then the applications has dependencies, and then the dependencies and the application, they are running in some runtime environment. It could be, in the case of Java, the JVM is running, but it's containerized in a Docker container. We have everything is running in an operating system, Linux distribution, whatever, a Linux distro, and then everything is connected with the drivers, and all of this is code that is executed, and they are the inventory of components that we need to build our thing. So SBOMs, the purpose is to make this inventory transparent for everyone to know what we are really producing. And this is very helpful to prevent software supply chain attacks. And this is a really serious deal. Like the EU cybersecurity strategy in 2020, they mentioned SBOMs. And very important, the President Joe Biden in 2021, he did this executive order for the national cybersecurity that mentions SBOMs. That it says that, okay, SBOMs are really important. And we should really take very seriously to list all the components of our software, and everything should be scanned for vulnerabilities. So in the military, in the really important businesses, like in the food production business in the US, there are regulations that they are starting to include SBOMs, like along with the software project, there should be an SBOM as well produced. So this is the last survey that I know of. It was for the Linux Foundation. They include 412 companies, and they just did a survey about the readiness of SBOMs, and they found that 95% are concerned about software security. And at that time, in 2022, 47% of them were using SBOMs. And they forecasted that by 2023, like by the end of last year, 88% will use, we have been using SBOMs. And I think this gives like an idea of the importance of SBOMs, of this. Like the governments are taking very seriously this topic. It's not just me here talking. So let's get back into the technical aspects. So let's talk about the components of an SBOM. So an SBOM they have three main components. The first one is the SBOM metadata. SBOM metadata, it means the standard that was used to generate the SBOMs. Today there are two main standards. The first one is SPDX from the Linux Foundation. The second one is CycloneDX from OWASP. And there is also metadata about the project in the SBOM. There are the coordinates of our project. We're gonna look into this soon. And also, very important, the inventory of all the dependencies. So this is the SBOM metadata. This is just an example of a Java library. As you can see, is on the left, there is an example for CycloneDX. On the right, you have the XPDX metadata. They are kind of similar. You have the timestamp and also the tool that was used to generate the SBOM. And regarding the project metadata, here is an example. For a Java library, you have the coordinates, the group ID, artifact ID, and version. You have the license, and also you have this very important hash of the library. And the hash is like a fingerprint. It tells you exactly that this library is what it is supposed to be. So it's a hash function. It generates a unique value. In this case, is 256. And it's very important because it's unique. So it is very well known to be very good for checking the integrity of the artifact and to avoid tampering. And it's a very important field that related with hashes and checksum with reproducible builds, which are also super important in the software supply chain. And also, the third component that I mentioned is the third-party libraries. So in this case, it's not only the direct dependencies, but also the dependencies of these dependencies. We will look into that soon. And it includes the version of these dependencies as well, and also the hashes. So we will know exactly what we have. And what we have is not small, is really big. So this is a dependency tree of a very well-known project in the Java ecosystem. Is the Spark project used for big data analysis. Is very, very huge library in terms of popularity, of use, of adoption. And this is the dependency tree that we have. It's just massive. It's more than 500 dependencies there. And if I am starting using Spark today, I will get all of this for free. All of this for free. Yeah, it's huge. It's like you go into one store and then you want some ice cream and then you go back home with the, you fill all your car with the glass. I don't know. It's a lot. What I don't want to eat that much. But this is what we have. So there are many, many issues. There are the dependencies that I don't know. This dependency, do I really use this? There are dependencies that are vulnerable. So I don't know this dependency, why I am having this, and now I'm taking care about Log4j thing that I don't even know. And there are also issues with licenses. So the licenses is a whole complex world. Like they are licenses that are not compatible between each other. So it's a big deal. So there are many use cases of SBOMs. Having this inventory is very useful. Like, I'm going to mention here just three, the ones that I think are the most important. First one, vulnerability scanning. Second one, compliance checking. And the third one, dependency management. For vulnerability scanning, this is the idea. We have our code. Then it enters a build into the build system. And then this build system, we generate an SBOM. And then this SBOM, it contains everything. It's going to be a scan using a scanning system. And then we generate a report, and then this report will get back to us, and then we could act rapidly because we will get this scan. And then we can change the dependencies, we can fix the vulnerabilities faster. That's the idea of vulnerability scanning. And also I mentioned that this compliance checking is very, very important, especially for big organizations, to meet the legal standards. Also to check the compliance between the different licenses. And overall, I think it's good for visibility, right? Because if you are giving to your customers the ingredients of your components, it means that you are being transparent in a way. That you are saying, okay, this is what I have. This is what you will have if you start using my tools. So the other important use case is dependency management. It's super, super important because with the SBOMs, we were able to understand our dependencies. We will be able to understand what we are actually using. We will look at dependencies, the ones that are not updated, and then the ones that are not even used, that we can remove because they are not necessary. And in 2022, with my research team, we published this paper about the software supply chain of Ethereum clients written in Java. Ethereum clients are just the program that runs the Ethereum blockchain. the nodes, and we look at the software supply chain. So we list all the dependencies there, and then we try to find if SBOMs were actually useful. And we found that yes, the answer is yes. There are many good things that could be done if using SBOMs, like updating dependencies, like finding vulnerabilities. And if all of this happens for the Ethereum ecosystem, which you know it has a very high stake in terms of digital assets. So what do you expect for the rest? And in the case of Java, we have the issues with dependencies. Now I'm going to talk deep about Java quickly. Most of you know in Java we have in multi-module projects, we have a parent project that we can extend for inherit. This is an example using the XML for Maven, and then is for the Spring Pet Clinic application. So our project inherits from it, and then we got all the dependency from the parent, and also we can declare dependencies in this case, and these are our direct dependencies. And the phenomenon that we know is that these dependencies also have dependencies, so we have transitive dependencies, and this is huge, and this is what causes the big picture of Spark that I just showed a few minutes before. So this is what we have in Java, and in Maven we can generate this tree. We have the Maven dependency plugin. So we run the command, and then we get in the terminal all these dependencies. And if we tweak it a little bit, like if you execute the commands on the right, then we can tweak this output into a JSON file, but it's not exactly like SBOM, but it lists all our dependencies. Is what we have today with the dependency management systems. And also in Gradle. So in Gradle, you have these dependencies task, which you were executing in the command line, and then it will list you all the dependencies. And but we don't have native support for SBOMs yet, as far as I know. But yeah, I know that the community is taking care about it because it's important. On the right, you see a comment made from a developer on November last year. Is saying that it would have been a good idea to have support for SBOMs. So hopefully they will act on it. So there are also dedicated tools to have a look at our dependencies. I will mention a tool that I developed and that I maintain. The name of the tool is depclean, and what it does is that it gives you the list of direct, the transitive, and the inherited dependencies. Now with this classification, and then it will give you the jar size of each dependencies. And more important, it will tell you which dependencies are actually used or not by your project, so you can remove them. And this is called deep loading, and it's something that I am very interested in. So check it out. So these are the ways that I mentioned to see all the dependencies, but there are also a dedicated tool for producing SBOMs in Java. One way, like the simplest way that I know, is using the GitHub UI itself. This is a feature from recent last year. Like they included this button. If you go into your project, you go into Insights, and then you go into Dependency Graph, and then there is a button there, Export SBOM. Then you get this SBOM in SPDX format. Yes, check it out. This is the easiest way to have an SBOM. There are more interesting ways, like using GitHub Actions, for example. Every time you create a new project on GitHub, GitHub recommends you to use the Salsa generic generator GitHub action, which is quite nice, because then you can not only produce this SBOM at every build, but you can send this SBOM for scanning as well. So this is a good way. And there are also dedicated plugins, like for example, the CycloneDX Maven plugin and the XPDX Maven plugin. On the right, you see an example of the CycloneDX plugin, how you can use it in Java. And yes, I will have a look at it with a demo soon. I will finally want to mention a more advanced way that I found just last week. Is about GraphVM. We have learn a lot about GraphVM these days here at JFocus. So basically, GraphVM included support for creating a SBOM along with our native image. So you create the great native image, and then you have some parameters in the native image command that you run, and then the SBOM will be packaged inside of native image. Is going to be zipped, of course, but then they also support tools to get the SBOM out of the binary file. And there are also plugins that support this for Maven. You can see an example on the right, but this is unfortunately only available on GraalVM Enterprise by now, but I just wanted to mention. So now I'm gonna do a very, very quick demo, an example of how to generate SBOMs in Java using CycloneDX Maven plugin. So I'm going to use this Spring Pet Cleanit application, which is widely known in the Spring community. It's like an example. I just forked the project. And then I would like to use the CycloneDX Maven project. So I just need to copy this XML code here. And now I am in my IDE. In IntelliJ, I have this Spring Pet Clinic. I'm in the pom.xml file. We are going to do is we are going to include this plugin here. The CycloneDX Maven plugin is gonna run on package phase, and then is going to generate an aggregated SBOM. So let's do that. Let's run Maven clean package, and I will just skip test just to make this very, very fast. So right now is compiling the application by Maven, and then you see there is here, there is a make aggregated boom plugin being executed, which is going to create an SBOM, going to analyze all the dependencies, and by default it put it on the target folder here. It should be, yes, there is a SBOM.json file and SBOM.xml file for those who love XML. Here is the SBOM of my application that I just mentioned. It's a CycloneDX. And yes, I have the SBOMs with all the different algorithms to create the checksums and the hashes. But we can do better than that. We can give this SBOM, this beautiful SBOM, to our customers, the clients of our library, so they can check it out, what we are shipping with our application. So let me do that. I'm just going to use JReleaser. Are you familiar with JReleases? And what I'm going to do is I'm going to make a new release of this project, but I'm going to include the SBOM in the GitHub release. So for this, I'm going to use this JReleaser YAML file, which I have here. So it's gonna be, yes, JRelease YAML file. So I want to update from version 3.2.6 to version 3.2.7. And this is the idea, is that I'm going to include the jar with dependencies and also the SBOM along with the release. So this is the idea. I will release the SBOM along with the jar with dependencies. I am making a jar with dependencies with the Maven assembly plugin because it's an application. And also, yes, almost not to forget to update the version. Should be version 7 here. Now, yeah, let me do a commit. Git commit. We are going to release version 7 at JFocus. Yes, just git git add, of course, the changes. Now we commit, and now we release. Now we are making a release of this. Is going to include this jar with dependencies here that we have, and it's going to release everything on GitHub. You see, the jar with dependency is being updated. Hopefully, it's gonna do it Yes, zoom, yes. And also the SBOM. So if we go back to the browser, and we go back to the Spring Pet Cleaning, my application, yes, then we could see that in their releases, we have this release version 3.2.7 at JFocus. And here's what you get. You get this SBOM JSON file, along with the Java dependencies. So this will allow anyone that wants to reuse our application to get this SBOM, to submit it to a code scan service that we are going to look, and then it will be like more transparent for them. They will know what we are actually shipping in this application, this sample application. So I will go back to the slides. I hope you all saw that it's super easy to generate SBOMs in Java. It's really easy. I do it with the Maven plugins, but this is not perfect. There are challenges with SBOMs as well as in any complex human-made thing. So I will like to mention two. The first one, it have to do with tool consistency. In last year, we did a research paper in which we analyzed the challenges of producing SBOM specifically in the Java ecosystem. So we took quite a few of the tools that we know that generate SBOMs in Java, and then we did this Venn diagram. We analyzed that you have on the left that the numbers are the number of dependencies that the different tools can find. And as you can see, there are some tools that find a different number of dependencies. So there is a little bit mismatch there, lack of consistency, which is a problem, because if we generate SBOMs, we want that the SBOM would be the same for every tool that we have. So this is important. This is still a challenge. So we want kind of agree in the tools that we use to produce SBOMs. It's very important. And last year, it was published this other paper. I'm showing papers because I have an academic background. But yeah, papers are super important. So if you want to really be at the state of the art, you should read papers. And there are many good software engineering papers. This is one of them, specifically on SBOMs. The title is An Empirical Study on Software Build of Materials, Where We Stand and the Road Ahead. It was published recently, last year. It covers many aspects of SBOMs. And specifically, I want to mention this one, which I think is very important. It's about sharing and distribution of SBOMs. It's quite sensitive. The SBOM contains everything we have. And if we have, like in a serious business, you know that everything we have, we don't want that everyone knows everything we have, because if they found vulnerabilities fast, then it will be a source of attacks. So it's very important to find secure distribution channels for SBOMs. That's very important, and this is still a challenge. And we are working on that as researchers, as engineers. So I will just wrap up. Hopefully, we'll have time for questions. This is the summary, like the conclusion. First one, SBOMs are essential for software supply chain security. As we have seen, there are many vulnerabilities that could have been detected quickly if we use SBOMs. We saw 3 examples, but quite many. Second, there is an increasing in attention of an adoption of SBOMs. So SBOMs are getting more relevant in the software landscape, and for companies, they are taking, even governments, they are taking very seriously the production and consumption of SBOMs. And also, super important, SBOMs are very well supported in the Java ecosystem. So we have plenty of tools to generate SBOMs. So we need to just start doing it soon. And yes, I'm just finishing. I will let you with the good resources that I will, if you like to read. So these are a few sources where you will find many other aspects of SBOMs that you can read, whether you are in the business, you are a practitioner, you are a researcher, or you are simply curious about SBOMs. So yes, that's it for me. Probably I have some time for questions if you have.
5 minutes for questions.
Yes.
Well, thank you very much.
Yes.
The one thing I didn't fully follow, you said that with these SBOMs that you would have noticed the vulnerabilities earlier, but how would that be different for just having, I don't know, OWASP dependency scan in your CI pipeline that would have noticed also that it's a transitive dependency, for example? Or if you wouldn't have log4j directly, log4j too?
Yes. Yes. So that's true. There are many tools that also perform this scan at build time. So every time we build, the scan is triggered. But the thing is that SBOMs is not only about scanning vulnerabilities. It's also about transparency. It's also about sharing what we have in our code base. So yes, there are dedicated tools that could serve the same purpose, but you can say the same about the code base itself. Like there are static checkers that looks for the vulnerabilities. There are plenty of tools for that. But the point is that SBOMs serve much more large purpose than just vulnerabilities, right? So, and that's the idea. And in the case of the checkers, this report is for you mostly, but the other consumers of SBOM, they may not reproduce it as well, because you are the ones who are using the OWASP checker, right? But if they want to use another checkers, they need this SBOM, and then you could have this diverse type of vulnerability analysis tools that, and then the intersection of them is going to be like the ground truth about the security of how secure is your project. You see, this is a use case. Did I answer your question? Yes.
Yes, I have a question. Is there a better match if you use the Maven plugin that he just mentioned? Then there's a match towards the NIST database on Gov, like group ID, artifact ID version, and that's just the best guess.
Mm-hmm.
Will there be a better match towards the database if you're using BOMs than compared to this Gov format?
Oh, yes. Yes. You mean the question is about the metadata about the project is like,
yeah, to avoid false positives, because it's only it's only guessing the match towards the database. They are not using the same format. I was wondering if the BOMs are using a better format to make the match to avoid false positives.
That's the idea, is to find a standard, like every artifact to have the right coordinates, the right identifier for the artifacts, and also to have more data, because today in Maven Central, for example, you have some metadata there, but for example, you don't really know about the license, and you don't really know about the hashes of the transitive dependencies of the artifacts. So you only know about the specific dependency, but not everything that you pull. And this is the idea of SBOM, is to have the whole package in one single file, in one JSON file. You have everything, and then you can distribute this or do whatever you want with this. But this is the idea, to have as much metadata as possible to serve the largest number of questions that you come out with your product, even your customers.
We have time for one more question, and I have two. So let's start here. We'll try, if you can be quick.
You said different tools would find different number of dependencies. What is the cause for that?
Yes, that's true. This is something that we found in a research paper that we did on the topic. There are plenty of tools. There are generic tools to generate SBOMs. Like they generate SBOM not only for Java, but for any programming language. So as you can imagine, having that many tools, you have many implementations, and when you have many implementations, you have different point of view, and all these tools have been used today, and there is a mismatch in the way the metadata that the SBOM contains. So it's different metadata, and this is a problem. So there are tens of tools to generate a SBOM, specific for Go, specific for Rust, specific for many programming languages. And so the community needs to work in the direction of having good tools that everybody knows, and these good tools should output the same SBOM. Otherwise, it could be very, very difficult to make fake comparisons about the components of the software projects. And this is something that we found out, like doing the academic research on the topic of SBOMs. But the paper covers many other aspects and many other different challenges, not only this mismatch between the content of the SBOMs. So have a look. It was published in Security and Privacy, which is a magazine, and that is not just very academic specific and complicated. So it's written for everybody to understand SBOMs, like the real challenges, in a more detailed way.
So you mentioned that the SBOMs are supposed to be complete, right? But then you take your pet clinic project and then you put it into a container which has dependencies. So now the SBOM is no longer complete. How does that work?
That's true. This is SBOMs are the top of the iceberg, right? So there is a lot of work to do in the idea of having like really an inventory of everything. This is what I included at the beginning. Like, of course, SBOMs only contain a small piece, and there is also plenty of information that is useful, like the version of the Linux distro used in the container, the operating system, everything. So ideally, we will have everything. This is what we would like to have, like to really know everything that we are using. And this is quite challenging, but I know that there are many good researchers working very hard on it. And very soon, hopefully, we will have better and more complete SBOMs.
We're running out of time, but you'll be around so you can answer more questions.
Yes, enjoy the coffee. I will be around there if you want to continue.
So we have a break, and we'll
thank
resume
you.
at 3:35. Thank you.